Hey guys, welcome back to the final session of the basic concepts of chemistry. Today we shall deal with the empirical formula, stoichiometry, stoichiometric equations and limiting reagents. These are the last parts in the basic concepts of chemistry. To start off, empirical formula of any chemical compound is the simplest positive integer ratio of atoms present in the compound. So empirical formula is just basically a ratio. We know that molecular formula gives us the exact number of atoms which are present inside a molecule. But on the contrary, empirical formula will simply give us the ratio and nothing else. A common example to be taken here is C3H6O3. This is the molecular formula C3H6 and O3. But if you try to get the ratio, then you will get the empirical formula, that is C1H2O. But for a molecule like C12H22O11, here the empirical formula and the molecular formula will be the same. Why? Because you cannot reduce it to a simple whole number ratio. This is an example of molecule of ethene, which shows that empirical formula is not equal to the molecular formula. Ethene, as we all know, has a double bond between its carbon atoms, and the molecular formula for ethene is C2H4. If you divide 4 by 2, the answer is 2, and if you divide 2 by 2, the answer is 1. So this is the ratio. If you apply it for the molecule of ethene, then you will get empirical formula as C1H2. And it needs to be kept in mind, or it has to be noted, that if mass percent of various elements present in a compound is known, then its empirical formula can be determined. So if you know the mass percent of any element, then you can easily find the empirical formula. Now let's move on to the stoichiometry and the stoichiometric calculations. Basically, stoichiometry deals with the calculation of masses and also volumes of the reactants and the products involved in a chemical reaction. So whenever there is a chemical reaction taking place, that is reaction between two reactants to give products, and a byproduct may be we use the empirical formula in order to calculate the masses of these reactants and the products which are undergoing a chemical reaction. Let's take the example of choco chip cookies. We all love choco chip cookies. So we, for example, take 1 cup of flour, 4 eggs, half a cup of sugar, 1 cup of butter and half cup of chocolate chips in order to make 12 choco chip cookies. Suppose I only want to make one cookie, then what is the amount of all these ingredients required? So how much of these materials will be needed just to make one chocolate chip cookie is the question. And the answer to this question is stoichiometry. Based on stoichiometry, we can find that how much of these ingredients are needed, how much of each ingredient is needed in order to make just one chocolate chip cookie. By dividing the individual quantities by 12, we can find the exact quantity required to just make one chocolate chip cookie. This is just an example to describe stoichiometry. Now let's consider it during a chemical reaction. When there is a chemical reaction taking place between methane, there is usage of oxygen. It leads to evolution of carbon dioxide gas and water as vapors. So by using stoichiometry, we say that 1 mole of methane reacts with 2 moles of oxygen. See here, the number here is 2, to give 1 mole of carbon dioxide gas and 2 moles of water. So we get 2 water molecules, mainly by the reaction of methane and oxygen. Using stoichiometry, we have made this statement. So, one molecule of methane reacts with 2 molecules of oxygen to give 1 molecule of carbon dioxide and 2 molecules of water. We can say so. Yes, we can. So, for example, if 22 liters of methane reacts with 45.4 liters of oxygen, then we will get 22.7 liters of carbon dioxide and 45.4 liters of water molecules only. Similarly, if 16 grams of methane reacts with 2, since there are 2 oxygen molecules, 2 into 32 grams of oxygen, we will get 44 grams of carbon dioxide and 2 into 18 grams of water molecules. We have made these statements mainly by using stoichiometry and stoichiometric calculations. Lastly, we come to a limiting reagent. Many a times when reactions are carried out, the amounts of reactants are different than the amounts which are required by a balanced chemical equation. So while we balance the equation, the amount of reactants differ. In such situations, one reactant is in more amount than the amount required by the balanced chemical reaction. So in this case, the reactant which is present in the least amount will get consumed after some time. So this reaction will be consumed in the reaction and further reaction will not take place. So the other reactant which is there in excess amount, it will be left behind. And the reaction will not take place whatever be the amount of the other reactant. So let that reactant be in excess, it will remain there only. Hence, the reactant which gets consumed first means which is there in the less quantity. It will get consumed first and the other reactant will be left out. So this reactant which is getting consumed first limits the amount of products formed. So based on that reactant which is present in the least quantity, the amount of product is determined. And this reactant which is present in the least quantity is called as the limiting reagent, because this reactant is the one which decides what will be the amount of product formed. The limiting reagent is the one which decides the amount of the product formed. So that is it for the basic concepts of chemistry. I hope that all the basic concepts of chemistry required have been understood well by everyone, and if there are any queries, suggestions, questions you all need to ask, then you all can surely leave it in the comment box. Thank you very much.